So when we're talking about solutions, we're dissolving a solid into a liquid. And the last time when you dissolve something like salt into water, that solid sort of disappears in solution. So what exactly is happening to that ionic solid? So let's take a look. So when we talk about solutions, one example here is that we have something called NaOH. This is your sodium hydroxide. And let me just get my pen here. Sodium hydroxide. What happens when this solid sodium hydroxide dissolves in water? So in order to talk about that, we have to look at how the structure of water is so unique, and how the structure of water actually is the universal solvent. So it's very good at dissolving solids. So when we look at NaOH, this is your sodium hydroxide. It's a very strong base. Starts off with these white solid, and when we put it into solution, it becomes a clear liquid solution. So when we look at the structure of water, this is your H2O, and the structure of water is pretty unique here. So you have your hydrogen bonded to an oxygen, and then with another hydrogen. And when we look at this one, there is actually 104 degrees with the bond angle, and the unique aspect of water is that this one actually is a polar bond. What that means is that because the oxygen, the element of oxygen, it has the tendency to attract the electrons to itself. That means it's going to pull the electron to itself. So it makes all of the areas surrounding oxygen here slightly negative. So we call this a slightly electronegative. So this is your lowercase delta, and what that means is that this oxygen has sort of a slight negative charge, and if oxygen pulls all the negatives to itself, then it leaves hydrogen a slightly positive charge. So this is your delta positive. So this actually plays a pretty important role, because in water, this is your diagram of water, how it's linked together. And when we talk about NaOH into solution, if we were to write this, you have your NaOH. This is your sodium hydroxide. It starts off with the state solid, so I'm going to put an S. And since this is going to go into water, what happens is that the water will break down this ionic solid into its ions. So you will actually have your sodium ions, Na plus, plus your polyatomic of hydroxide, and this is your minus. And to indicate that it is in solution, we're going to put AQ for aqueous as a subscript. So this AQ means aqueous, and that means that it is dissolved into solution, into water. So if we were to look at this, what would this look like? So since your NaOH is put into water and you have these two dissociated ions, what you're going to see is that once you put your NaOH in, you're not going to have your solid anymore. You're going to have your Na plus, and then you're going to have your hydroxide swimming around into water solution. Into solution. And that's what's happening. And why did I talk about water in the beginning? Well, the importance of the water is that it's the water that breaks this solid apart. So because this sodium has that slightly positive charge, this is going to be attracted to the oxygen side of your water. So you can see that, remember, because your oxygen has that slightly negative charge, this slightly negative and positive charge will attract each other. And because hydrogen is a slightly positive charge, this slightly positive charge will be paired up with the slightly negative charge of your hydroxide. So if I were to draw a bunch of water molecules here, I would have the oxygen, the slightly negative one, beside the slightly positive, and your hydrogen will be right beside the hydroxide, because that is your negative charge. So this is what they call the solvation process. This is how they dissolve, and using the charges of water, it makes it break down the ionic solid. So this is another diagram of this. This is a lot better drawn out. So when your NaOH solid were to dissolve in water, you have your Na plus ion and OH negative ion separated or dissociated. So just likewise for this one, this is your positive and your OH is negative. So that's your NaOH dissolving solution. So let's look at another example here. Is that copper 2 chloride is a popular one. You know that copper 2 chloride starts off with this blue, sort of green, teal, turquoise solid. Once you put it in solution, it changes into this color. So what happens, how do we write this equation? So we start off with copper 2 chloride. This is your solid, so I'm going to put an S. This is going to go into solution, and it's going to break down and dissociates into its ions. So I know that right now it says Cl2, but when you dissociate into ions, these ions are independent, they're single. So how do I balance this? Well, because you have two Cl's here, I'm going to put a 2 here, and copper still stays the same. I'm going to have a copper, and then we have to find out the charge of copper. Well, this one has to be a +2 charge because there are two -1 charges, so then the copper has to be a +2 to balance that out. And then I have to change this to state that this is in solution, so I have to put AQ here and then AQ here. So then what does this look like in solution? So let's check this out. So in solution here, this is going to be my ions because they're all going to be dissolved. So I'm going to have your Cu +2, and then I'm going to have Cl -1, but for every copper I'm going to have 2 chlorines, and that's what it looks like. And if I were to add the water, I'm going to put the oxygen that's slightly negative closer to the positive, and because these chlorines are negative, I'm going to put my hydrogens because they're slightly positive beside it. So that's what it looks like in solution if we were to see. So this is just an introductory video of what happens when you dissolve an ionic solid, and the key thing is that all these ions will be dissociated or separated when they're in solution. That's why you never see that solid into your solution. So that's your first video. Thanks for watching.